Okay, this is a quick little tutorial on density. You were just watching a video on physical properties of matter, and so density is a physical property, but I want to get a little bit more in depth into it and make sure you know what density really is. So it is a physical property. It's going to describe the relationship between mass and volume and how that works. The exact definition of density is that it's the amount of matter in a given amount of space. So it's the amount of stuff that you shove into that space. So your body has matter in it, and therefore your body has density because you have a bunch of stuff packed into that space. This diagram right here shows an area of low density versus an area of high density. So the area that has a lot of the red balls is going to have the high density area versus the area that does not have a lot of the red balls. They're the same volume. The cubes are the same size, but they don't have as much stuff. The one on the right doesn't have as much stuff packed into the cube, so it has lower density. I just threw up a picture of a density column. You can see water is green. And water has a density of 1, which my next slide shows. But it shows you that vegetable oil, rubbing alcohol, lamp oil is all less than 1 because it's floating. Ping pong balls on the very top of that. And below that, dish soap, milk, maple syrup, corn syrup, and honey are below water, so they must have a density greater than 1. I also have one of those things on my desk, so you can see that density column. If you compare a golf ball versus a ping pong ball, they're taking up the same space, they have the same volume, but the stuff that's packed into that space is different. You see the mass of the ping pong ball is 2, while the mass of the golf ball is 46. So you have a lot more stuff packed into that golf ball versus the hollow ping pong ball. This is going to make different densities of these two objects. And to calculate density, you need to know a couple things. First, you want to measure the mass, and that's supposed to be mass is represented with an M and volume is represented with a V. So it's D equals M over V, and the units are grams per milliliter. That's generally what you're going to get. But if you have a regularly shaped object, you could get grams per centimeters cubed because you can use your ruler to measure length with height. So two different ways to write that, but you did a lab before that showed you that milliliters are equivalent to grams, centimeters cubed, so you could write either way. But generally, if it's a regularly shaped object like a cube, you would put grams per centimeters cubed, and if it was something like a golf ball that you needed to use water displacement to measure the volume, then you would use milliliters. Okay, a little cheat sheet. If you wanted to rearrange the formula for density, you would draw a circle. Cut that circle in half and then put a little line down. You know that D equals M divided by V, and the long line is going to represent a division sign. In the other little space, you're going to just draw your D. So if you wanted to know what density was, the formula, you put your hand over the D. D equals M divided by V. If you had to solve for, let's say, mass, put your hand over the M. M equals D times V. You're blocking the M with your hand. You can only see D and V, and the little line represents multiplication. So M equals D times V. So those are just little ways to rearrange the formula if you ever had a problem where you needed to solve for something other than density. Knowing that the density of water is 1, you can determine how a substance behaves. So if something floats or sinks, you can determine this based on that water's density is 1. If the object sinks in water, the density must be greater than 1. And if the object floats in water, the density must be less than 1. So here's a good question. Why do ice cubes float if they are in fact made of ice and ice is water? You would think they would have the exact same density, but ice cubes float. So how does that work? I'm going to let you think about that for a second. In fact, I'm actually going to not show the answer right now. I want you to think about it, write it down in your notes. We're probably going to talk about it in class, but the answer's underneath the blue box. I know you really want to see what's under the blue box, but like icebergs, why are they floating in water? Why are ice cubes floating in water? They're made of the same exact substance. So tell me about that and come talk to me about it. Let me see if you are on the right track. Here's a practice problem for you. If the mass of a rectangular solid is 152 grams, its length and width are each 3 centimeters. Its height is 2 centimeters. What is the formula for density of this rectangular solid? So write down the formula. First, you got to calculate the volume of the cube. So this is a regularly shaped object. Length, width, and height is what you would use to calculate the volume. So let's write that. So length times width times height would give you the volume. You have been told the mass already in the equation, and now you got to calculate the density. So I will leave you to that. You can stop the video and try to figure that out, and we'll check it together. Second problem is a piece of metal has a volume of 38 centimeters cubed. So it's centimeters cubed because it's regularly shaped, length with height in centimeters. It has a mass of 277 grams. Calculate the density of the metal and identify it based on the information below. So let's see. Calculate that density. And then in class, you'd be able to move these zinc, iron, tin, and lead around into the checking box to see if you got it right. But I'll leave that to in class. But go ahead and calculate the density, and we'll figure out which exact metal it is. And the last one, the density of water is 1. We know that, gram per milliliter, because it's not a regularly shaped object, it's a fluid, so we have to measure the volume with milliliters, so it's grams per milliliter. The density of corn syrup is 1 gram per milliliter. The density of vegetable oil is 91 grams per milliliter. I have a beaker here, and in class you'd be able to move these things around, see what I mean, and put them in order of who's floating on top of what. Let's move this out of the way. Who's floating on top of what? So think about how that would work, maybe draw it in your notes, and let me see it later on. So thanks a lot for watching. I really appreciate your attention as always, and can't wait to see you again.